Well, here we are. It's Thursday. We made it. So we are talking about section 2.6 and 2.7, proving statements, and now we are on day 4. So this is our last day of chapter 2, and you will be taking a chapter 2 test on Tuesday of next week. So don't miss Zoom tomorrow because we will be talking about reviewing for the test that's next week. Today is the 17th of September. And I just wanted to remind you about the resource that is a really good resource for you to use. If you don't have this printed off somewhere, you really need to print it off. And again, you will want to use the printed notes, not your own notes, because there's way too much information on here to write down for you to try to do this by hand. We're going to continue to apply complex reasoning, so deductive reasoning, to 2-column proofs. So there's a column of statements like the algebra work and a column of reasons like the properties, except it's all geometry this time. Our objective is a little different because the 2-column proof we did yesterday was very straightforward. A led to B, or step 1 led to step 2 led to step 3 led to step 4. Today we're going to talk about how an actual full-blown proof would work. So we're going to apply complex reasoning to complete a 2-column proof using combining of statements, oops, might have, oh, let me get that moved over. So combining of statements and information from a diagram. And sorry about that, the blank's not long enough. Okay. So I just wanted to remind you the structure of a proof. There's the question and then there's the answer. So the question is given, so that's your start. And what you intend to prove is your end or stop. You'll have a picture somewhere up in the question. It's for reference. And or information. Yesterday it was just for reference, and today it could be information. So the first 2 things you do in a proof, you always do in a proof. If it's a basic proof like yesterday or a little more fancy proof or like today, first thing you do is you're going to write down the given statement. Where do you plan on starting? Remember, if there are multiple givens, given being kind of a noun there, if there are multiple givens, they can be written at different times. So we're going to look at 2 different scenarios where we have 2 givens that are unrelated and 2 givens that are related. And so we're going to separate them in one and not in the other. Then remember, the whole point is to tell me what's logically next. What comes next? What comes next? And so that can occur multiple times. Now I know it says second, but it doesn't mean step 2. It means second, you're going to try to roll with it or run with it. And when you can't do that anymore, then you'll move on to another option. So these first 2 are what you did yesterday and what you did Tuesday. And so we used postulates, theorems, definitions, and properties. Later on, we're going to use what are called corollaries, and it's just a different type of theorem. Okay, so now with today's lesson, we're going to get to a point where we can't keep rolling. Like the ball is stopped. Now what do? I'm not done with my proof, but I keep going. So one thing that you can do is you can either go back and check to see if there's another given, but if there isn't, go up and look at your diagram and see if there's something that you can tell from the diagram. Sometimes you can use a definition, because we know by looking what vertical angles look like. That's a definition. You could look at a picture and know that it's the segment addition postulate. You could look at a picture and know it's the angle addition postulate. So all three of those definitions, and angle addition and segment addition postulate, all of those have come from you just looking at a picture. If you think about chapter 1 and chapter 2, you just looked at a picture and knew those things. So it's the same thing in a proof. You just look at the picture and you know those things. These are not the only ones, so I'm going to put etc. Those are just the most common ones. A definition of something tends to be like definition of vertical angles or definition of linear pair, segment addition postulate, angle addition postulate. The more we do this, the more you'll understand what can come from a diagram, but those tend to be the things. So the question is, why is there a second line? Well, it depends on how big you write. Okay. So we wrote the given. We started rolling downhill with everything we knew. We got stuck. There wasn't a second given, or maybe there was, and we kept rolling down the hill, and then we got stuck. So then we looked at the diagram and said, hey, what do I know about the diagram that's helpful? Sometimes you'll know stuff about the diagram and it's not helpful, but what's helpful? And so so then, once you write stuff from the diagram, you try to kind of roll again. So step 2 here is constantly being played. Like every time you write something, you're going to see if you can roll with it. And if you can't, then you're going to go on to doing something else. So you've written the given, you've rolled with it, you've written something from the diagram, you've rolled with it, and you're not done with your proof. Okay, now what do I do? You're going to combine statements. Combining usually is properties. Substitution property, transitive property. Not necessarily the only ways. Usually properties, but not always. It could be a theorem. So for example, congruence of angles is transitive, could work. So things that put two lines together, you're going to try to combine them if it's helpful, only if it's helpful. And then once you finally said everything you could possibly say, you should be finally down at the proof, where you intend to end or stop. And remember, just like yesterday, that is going to be a postulate, a theorem, a definition, a property. You are never going to say at the end, hey, look, I've proved it. It's proven. Because, yeah, that's not even an answer. And definitely not given. Because even though it's written in the question, this is not given. This is telling you where you should end. Okay, so let's do a proof together. And we're going to run through everything that tells me to do. First thing you should do is write down the given. So let's look at our question. Our question says segment AB is perpendicular to segment BC. So I like to mark that because perpendicular means a right angle. That may end up in the proof or maybe not, but I like to mark it so I can see it. And then the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. So there are two different given pieces of information. They are not related. One is about segments and one is about angles. So I'm going to choose to separate them. Now in the end, I should be able to prove that the measure of angle 1 and the measure of angle 2 equals 90 degrees, which looks a whole lot like this given, but remember, this isn't given. This is where we're going to end. So I'm going to start with the first given. How do I know that segment AB is perpendicular to segment BC? Because it's given. So now I'm going to do what I've done for the last 2 days. Can I go from step 1 and get step 2? And if I can, why? Well, let's see. I have perpendicular segments. Does that give me a right? Well, yes, it does. If two lines are perpendicular, because remember, upside down T stands for perpendicular. If two lines are perpendicular, then they form, okay, now we get two choices. Remember, there's two choices. They either form one right angle or four. One or four. So this is talking about one. So you can choose. You can say they form one right angle, or you can say they form four right angles. I personally like to say four, but I know most of you are going to say one. So they form a right angle. And again, I'm going to abbreviate it because I only have so much room to write. So if two angles are perpendicular, then they form a right angle. Okay. Now I'm going to try to do again what I've done the last 2 days. Is there a way that I can go from step 2 to step 3? Am I still talking about the same angle? Yeah, I'm still talking about angle ABC. So can I go from a right angle to 90 degrees? I think I can. If an angle is a right angle, then it measures 90 degrees. Okay, so far so good. Okay. Let's see. I was talking about the measure of angle ABC, and number 4 has a measure of angle ABC in it. Okay, so it kind of looks like they're related, so I'm still trying to roll with it. I'm still trying to do that second thing, roll with it. But where the heck did angles 1 and 2 come from? Like, poof, they just showed up in the proof. Okay, so this is where we go, okay, I rolled with it until I couldn't roll anymore. So where did I get number 4? It's either a second given, or it's from the diagram, or I combine some stuff. Well, the easiest thing to do is just go see if it's a second given. There. Oh, look, it's the second given. Given. Ta-da, given. Okay. So as soon as you write that down, then we start that whole roll with it thing again. We go back to this second one again. Can you roll with it? Can you come up with something else? So is there any way I can get from the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC? Can I get from there to step 5? And I really do think I can, because this is the same, this is the same, this is the same. Like all, the first 3 things, the left side's all the same. The change is right here. But that's okay. In step 3, I knew the measure of angle ABC was 90 degrees. So I'm going to kind of show that again. Angle ABC was 90 degrees. So they all kind of go together. So this is a combining. I'm combining it. I went from a measure to a measure to a measure. That makes it a property. All of this is identical. I've just replaced one for the other. So it's the substitution property. One more time. I wrote the given. Lines are perpendicular, so they form a right angle. A right angle's measure is 90 degrees. So these three went together. I couldn't go any farther. I know some of you are like, well, couldn't you say that's a right angle? Well, I already did, so I can't say it again. So since I couldn't say anything else, my next statement, the first thing I'm going to do is say, is that a given? Yes, because remember there were two given. So this is the second given. And then I tried to roll with it. And I did, 4 to 5. Man, they look a lot alike. There was just one number replaced because number 3 tells me I can replace. So that's the substitution property. So then these two went together because of those 3. Okay. So I know some of you are like, can't I do definition of? Yes, you can. Okay. So this one is definition of perpendicular lines. This is not definition of a right angle. Where number 3 is, oops, I forgot my period earlier, definition of a right angle. Because the definition of a right angle says its measure is 90. Okay. Number 2, which I got to bring down into the video here. Okay, so this one, you'll see that we have 2 givens. Point M is the midpoint of segment AB, and point B is the midpoint of segment MD. We have 2 of them, but they're not different. They're saying the same thing about different segments, but they're saying the same thing. So I'm just going to write them once. So that's given. And yesterday we talked about this. If you have a midpoint, it makes congruent segments. So you could say that. You could say midpoints make congruent segments. Or you can put it in if-then form if you want. Or you can say definition of a midpoint. Oops, I'm way off the screen. Sorry about that. Okay, so we know midpoints make congruent segments. We know congruent segments have equal value. So if 2 segments are congruent, then their measures are equal. If 2 segments measures are equal, then they're congruent. Well, now that's going backwards. So we're done at this point. These 3 went together and we're done. So now, how do we know the length of MD equals the length of MB plus the length of BD? Did it come from the given? No, it didn't. So if it doesn't come from the given, then we're going to go to the diagram. So how do we know this entire length MD is the same as these 2 little pieces added together? Because the segment addition postulate says so. Does step 4 give me step 5? Well, it definitely looks like it could. So far, everything is identical. Like, it's identical. The only difference is right here. So when was the last time we talked about the measure of segment BD? In step 3. And what do we know about it? We know it's the same as the measure of MB. So we substituted. So this is the substitution property. Can we go from step 5 to step 6? You kind of really have to look at it, but the answer is yes. Same, same, and then we took these two and we made them the length of 2 of MB twice. So that's the distributive property. I'm sure you don't remember that from algebra because it's been a while. Or it's simplify. I will take either one of those. And somebody may say, can't you call it combining like terms? Yes, you can. That will work too. Okay. So here's the bad thing about this proof, and it's always irritating to me, and it's been irritating to me since I was a sophomore in high school. This first piece of information didn't do anything for me. You'll notice we did not use it ever in this proof. So why did they tell us that? Because sometimes that happens. They just give us more information than we need. It's irritating, but that's the way it is. Okay? So, midpoints make congruent segments make equal measures, segment addition postulate, substitution, simplify. Are any of these a definition that I haven't pointed out? Good. It's number 3. It's definition of congruent segments. So if it is a definition, you can say definition of instead. I do highly recommend that you go and look for other videos other than just my teaching of this lesson, because the more you see of them, the more you hear other people describe how to do it, the better off you're going to be. But first and foremost, write the given. Roll with it, which what I mean is do yesterday's lesson. 1 gives you 2, 2 gives you 3. If at that point you can't keep going, then look for a second given, look for something from the diagram, or combine things through substitution property, transitive property, things like that. Okay. So I don't want to cause confusion, but I am going to go back to example 1 for just a second. Okay. So in example 1, we definitely said that was the substitution problem there at the bottom. But you will notice we replaced the end of an equation, not inside of it. So let's look at the difference between the two examples. Okay. So in example 1, we replaced the end of the equation. And in example 2, we replaced within the addition problem. I know it looks like the end, but it's not. It's within the addition. Okay. So if it's within the addition, within the body, it has to be the substitution property. If it's at the end, all by itself at the end, you can say it's the transitive property. Again, please do not forget that there is Zoom tomorrow. We're going to review this. Make sure that you are practicing this because you do have a test Tuesday next week. The more you practice, the better off you will be. I really do highly recommend you seek out your own videos on these on proofs as well. And they don't go away, even though we're done with chapter 2. We have proofs in chapter 3, chapter 4, and chapter 6.